Hello students, so next is our application of determinants and matrices. Okay, so application. Now we know how to find inverse of a matrix using determinants, using matrices. Okay, so can we apply that so that we can find a solution of something? Okay, as so we can solve a system of linear equation, okay, using inverse of a matrix. Okay, so suppose there are system of linear equations. If you are taking 3 by 3 matrix, then suppose there are three equations are given: a1x plus b1y plus c1z equal to d1, a2x b2y plus c2z equal to d2, and a3x plus b3y plus c3z equal to d3. So these equations can be represented in the form of matrices. Okay, so our A matrix become coefficients a1, a2, a3, then b1, b2, b3, and c1, c2, c3. Okay, then it is multiplied with the variables x, y, z. We will get d1, d2, d3. So using this equation we can find solution of this equations. Okay, so this matrix is A, this matrix is represented by X equal to some B matrix. So our X matrix, that is solution matrix, is given by, if you multiply here A inverse both the sides, you will get here. Okay, so X is A inverse B. So using this equation you can find inverse of a matrix. Inverse you can find using adjoint method, okay, or a matrix method. So that inverse you have to substitute here, multiply by B matrix, you will get the solution set of this linear equations. Okay, so now we know that A inverse exists if and only if A is non-singular matrix, right? So there are some cases, okay, where suppose A is singular matrix. We have got A to be singular matrix, that is determinant of A is 0. Okay, so you have to calculate adjoint of A into B. Okay, adjoint of A into now there are two cases. First one is if this multiplication is not equal to 0, okay, then the solution does not exist and the system of equations is inconsistent. Okay, so this implies that solution does not exist. Okay, and so it is inconsistent. Inconsistent is what? Inconsistent means the solution does not exist. Okay, the equations, system of linear equations which has no solution, that type is called inconsistent. Okay, system. Second is you have to check adjoint of A into B is equal to 0. If it is equal to 0, then system may be either consistent or inconsistent. So there is a possibility that it can be consistent or inconsistent. So either it has infinitely many solutions, okay, or it has no solution. Okay, consistent means it has solutions. So this is basically the case of infinitely many solutions. So these two cases you have to remember. Okay, when you are given A to be a singular matrix. Okay, whenever you get A to be a singular matrix, you have to check for these two conditions, and then this will decide whether your system is inconsistent or consistent. Okay, let's solve one question. Okay, if a system of linear equations is given, I am taking 2 by 2, 5y equal to 1 and 3x plus 2y equal to 7. Okay, so represent this in the form Ax equal to b. So your A matrix is 2, 3, 5, 2. X is xy, and B matrix is 1 and 7. Okay, so first you have to find A inverse. First thing you have to find your determinant, because we should know whether it is a consistent or inconsistent, means a solution exists or not. So determinant of A is 4 minus 15, so it is minus 11. So it is not equal to 0, so we can say that solution exists, that is inverse exists. Okay, now let's move. So x is given by A inverse b. Okay, so find out A inverse. A inverse is nothing but you have to calculate your one upon determinant of A, that is minus 11, and adjoint of A. This, since this is 2 by 2 matrix, I can directly find out the adjoint. So this you have to interchange, and this you have to take negative sign. Okay, so this is your A inverse. Now you have to multiply it with B. So I'll write here 111 so minus 1 upon 11 you can keep outside. So multiplying, you will get 2 into 2, 2 minus 35 minus 3 plus 40. Okay, so you will get here minus 1 by 11 minus 33 upon 11. So final answer is minus 3 plus 3 upon plus 3 and minus 1. These are your x and y. Okay, so same way you have to do it for 3 by 3 matrix. Let's solve one question from exercise 4.6. Okay, so you have to examine the consistency. Okay, so I'll take third one. Okay, third question. X plus 3y equal to 5 and 2x plus 6y equal to 8. Okay, now looking at these numbers, you will understand that this determinant is coming equal to 0. That is, this determinant is singular. Okay, so don't get confused. Okay, determinant of A equal to 0, it is singular. So for that you have to find out adjoint of A into B multiplication. that will give you whether the system is consistent or inconsistent. So first you write down your A matrix, AX equal to B. So A matrix is 1 6 2 3 into XY 5 8. Okay, this is your A matrix, this is B matrix, and if you take the determinant you will get equal to 0, so it is singular. Now check for adjoint of A into B. So adjoint of A multiplied by B, that is matrix multiplication. Adjoint of A, I'll write it directly. So changing the sign, and B matrix, let's multiply 30 24 minus 10 plus 8. Okay, so this is surely not equal to 0. Okay, it is not equal to 0, so you have to go for the condition where adjoint of A into B is not equal to 0. So solution does not exist. This implies solution does not exist, which implies it is inconsistent. Okay.